Hey everyone, this is going to be an introductory presentation on Substrate. I'll be briefly discussing the underlying mechanisms that are being used by Substrate, and in the end, I'll provide a quick demo on how to actually use Substrate to deploy your own fully functional blockchain on your local machine. So, first of all, my name is Khaled. I am a master's student at the University of Manitoba, and I'm part of the Trustworthy Computing and Distributed Technologies Lab, or TCDT for short. Um, so this was originally designed to be an interactive presentation, but I'm here just talking to my screen. So this is where I'd ask you, what do you think a blockchain requires to function? And then you'd answer, oh, it requires storage. And I'd be like, yes, correct. So it requires storage, obviously, because you're trying to store your chain somewhere, your transactions that are contained within blocks and so on. So some database is required, and one other major thing that is required for a blockchain to function is networking. So a lot of times we'll want nodes to communicate with each other, for example, to gossip transactions to one another, or come to a consensus on the current canonical chain. So peer-to-peer networking is a major part of blockchain. The last component that you'll probably want is an execution runtime. So you need some way of actually executing the transactions that are being submitted to the blockchain in order to have a valid state transition. Um, and so this is where Substrate comes in. Substrate is basically just yet another blockchain platform, but to be more specific, it is a software development kit that basically just provides some default implementations for all of these things that you need to build a blockchain. Um, Substrate itself was actually originally used for Polkadot. They utilize, they build a lot of different chains, and so they were like, okay, we're building the same components over and over again, so why not just take it out into a software development kit and then build our chains on top of that SDK and just customize what we need to customize. Uh, However, even though it is it was originally used for Polkadot, we can just use it to build our own standalone blockchains, which I will show later on in this video. So the architecture of Substrate is, well, at a glance, it looks simple, right? You have the whole Substrate node, which is comprised of two main components. The one component is just called the outer node, and the other is the runtime, the actual runtime. The outer node is just responsible for any outside world interactions, so any networking queries, any RPC requests, storing stuff onto the database, consensus, all of that stuff is handled by the outer node, whereas the runtime is only concerned with handling on-chain interactions. Um, so running any transactions is going to happen through the runtime. And so here you can we can have another look at the architecture. Substrate is actually built around pallets, which we'll look at later. So you'll see that, for example, the balances or account balances right here is actually supported by or implemented by pallet balances. And these pallets are just basically normal Rust crates that just provide functionality, basically, like the necessary functionality for the runtime. And so all of these things are implemented as Rust crates. So the consensus itself is just the SP consensus, and so on. The So this is just the Rust part, and a big part of Substrate is that it uses WebAssembly for its runtime, and this allows for forkless upgrades, whereas without using WebAssembly, normally if you want to upgrade your blockchain, you'll have to undergo some kind of hard fork in order to implement all the upgrades that were being presented. Whereas with Substrate, you can just store the new WASM runtime on the chain, and then all nodes can just update to that, or utilize that WASM runtime and just carry on as if nothing happened without having to fork anything, which is Very cool. This is a neat little diagram just showing how Substrate actually kind of decreases the complexity. Um, like even though Substrate itself is just an SDK, if you want to work with the inner implementation of Substrate, it'll take you a lot of time to actually get through development because you're working with like the actual libraries or the network. You're going to be implementing your own logic for networking, for example, or consensus. Um, but we're going to be, well, in this video at least, we're going to be talking, we're going to be only dealing with the node template that is provided by the Substrate team, and we'll see how to customize it and quickly deploy a chain that we can have like customizable and everything. Um, so there are four network types that you can deploy using Substrate. The first one is just a solo chain, which is just a chain that exists on its own and doesn't connect to any other chain. For example, Bitcoin, Ethereum, all these are just solo chains. There's also a private chain where only nodes that have permission to join the network can actually join the network. So Ethereum and Bitcoin are obviously public blockchains. Any node can join the network. And then the last two are actually specific to the Polkadot ecosystem. So you have the relay chain, which can provide like a decentralized communication between blockchains. It's for interoperability between blockchains, and then which is Polkadot itself basically, and parachains, which are just chains that connect to the relay chain to utilize its interoperability capabilities. The nodes that can be deployed onto a blockchain also come in different types. So first type is a full node. A full node basically stores data with an asterisk, and we'll see why later. What the full node does is it participates in all the operations to maintain the blockchain itself. So it participates in consensus and all of these things. But so this is where the asterisk comes in. We only store the most recent blocks on of the chain. We don't store the whole chain on a full node, but we do store all the block headers of the chain, and so the full chain can technically be rebuilt using all these block headers by just re-executing all the transactions and everything. But usually you don't do that with a full node. You instead just go to an archive node, where, well, from its name, an archive node just is used as an archive. It stores all the previous block data on its actual like storage, but it can also participate in network operations. Usually not the case. Usually just provides the storage resources and calls it a day. And the final type is the light client. A light client doesn't store anything. It requires minimal resources. You can even run it in your browser. And so all it does is just syncs with any node and has like the latest block header basically, and that's it. It can interact with the blockchain itself by sending some RPC requests to some full node that is participating in the chain. And so earlier I was talking about pallets, and well, here it is. So pallets are just functionality that are implemented as cargo crates that can be imported into the runtime and just be used by the Substrate node that you have. And so these are examples of like default pallets that are actually just provided to you by Substrate. You'll see some things that are probably going to be used in most of your nodes, like Aura, Babe, Grandpa. These are for the consensus. You have sudo as well, that is for running permissioned or administrative functions, like for example upgrading the runtime. The assets palette provides assets, obviously, and so on. There are a bunch of different palettes that you can use. There's a contracts palette if you want to deploy like smart contracts onto your node. a lot of palettes that you can play around with. And you can also implement your own custom palette, which we will be doing in the demo. Now, when it comes to storage, Substrate uses RocksDB as its key value store, and they use an implementation of the Merkle-Patricia tree. Uh, the This is done so that you can, obviously, for like if you were using a Merkle tree, you can just verify that the chain state using the root, but the access times are too slow, log n, and so they have like a custom implementation of the Merkle-Patricia tree on top of RocksDB, so that they can be used as key value pairs. This is kind of like a very abstract overview of how storage is implemented in Substrate. There are different storage types that you can use in your palettes when coding or programming your own palette in Substrate. The first is a storage value, which is, you can think of it as a variable. Basically just stores a single item, and that single item can be a primitive or a struct or a collection, whatever it is. You can have a single key map. It's just a normal hash map, basically. That you can think of it that way. You can have a double key map, and so this way you'll have like 2 keys per value, and this can be used like this is useful if you have a lot of like different subcategories, for example, that you want to have. So for example, you'll have a key 1 and you'll query a lot of things within key 1. In that case, you'll probably want to use a double key map. A multi-key map also, like, it's just the same thing as a double key map, but more keys. So it's pretty flexible, is the conclusion here. Now, before getting into the next section, I want to define a few hash functions that are being used in Substrate. The first is the 2x hash, which is a non-cryptographic fast hash function. I'm not going to go into detail with any of these. If you're interested, I'm pretty sure they provide detailed explanation of all of this stuff on their documentation, but you can also just Google it and you'll find a bunch of information on this. They also use a Blake 2128 concat, which is a transparent cryptographic hash, and they use scale encoding, which is something that is just used in the Polkadot ecosystem. It's a minimalistic encoding scheme, basically. And so we're going to be using all of these different functions for accessing storage in the next section. So to access anything within storage, you'll need 3 things. You'll want the name of the palette that you're interacting with, the storage item name, so whatever it is, whether it be like a single value storage, a single key map, whatever it is, that's a storage item. So we'll want its name, the defined name, and we'll want to know what hashing algorithm it's using. And I'll just run through this using a scenario. So imagine you want to check the free balance of Alice's account. And so we're going to use the balances palette because it stores the free balance information in a free balance map. And so the free balance map just maps the address to the balance value. And so from this information, we know the name of the palette, which is balances, the name of the storage item, which is free balance. And so to kind of create a storage key so that we can access whatever information that we want, we'll hash the palette name, the storage item, and we'll also hash the scale encoded value of the storage item key, which in this case is going to be like Alice's address, because the free balance map maps the address to the value, so the address is the key. And so this hash function h is going to be the 2x128 hash for the palette names and the storage items. But storage maps can have their hashes specified. like, so you can use different hashes basically, and but they use Blake 2128 concat by default. And so the final constructed storage key in our case is going to be just the 2x hash of balances, which is the pallet name, and the 2x hash of free balance, which is the storage item name, and then the Blake 2128 concat, because that's the hasher that is being used within free balance, of the scale encoded Alice address. I'm just using / Alice as a mnemonic. Okay, so by the way, you'll only need this if you're going to be interacting with the RPC interface directly without using any libraries that are provided by Polkadot for whatever reason. There might be a few reasons that you want to do that, but most of the time we're probably not going to do this, but this is good to know anyway. This takes us to the transaction lifecycle within Substrate. And so the lifecycle here is straightforward actually. So you'll have some transaction. Some client is going to submit a transaction to a node within the blockchain, and if this node is not an authoring node, it just gossips the transaction to other nodes until the transaction reaches an authoring node. Once it does reach an authoring node, it gets validated by the authoring node by calling the runtime and actually validating that the transaction is valid. And then it gets added to the transaction pool where it's waiting to be included within a block. Now, within the once it actually goes into a block, the transactions are ordered based on. So you can provide you can specify priority for transactions in Substrate. So they can be ordered by priority, but they are primarily ordered by whether the transaction is inherent or not. So there are some inherent transactions within nodes, like for example the block timestamp in transaction, which provides the timestamp of the block. This is inherent to the node, and so that transaction is always going to be included within the block, or was going to be like included first within the block, and then we're going to be including transactions based on priority. And so if we have transactions from the same address, we're gonna order them based on their nonce. If they have the same nonce, then we're gonna order them based on the fees. So the higher the fees, the but you'll probably discard the replicated nonce anyway. So once they're ordered within the block is then just announced to the network and is just broadcast to all nodes, and it is then just added to the chain. Now, sometimes you're not transactions are not going to be able to be added into the block, and so this may be because the transaction there's a concept called weights. So each transaction is weighted based on its number of reads and writes onto the chain, and so that the higher the number, the bigger the weight. And usually you have a certain specified weight for each block in Substrate, so that you can target a specific time for block authoring. So for example, 6 seconds by default. You want to author a new block every 6 seconds, and so you want to limit the size of transactions that can be included within each block. And so if the transaction is going to, like, if the inclusion of a transaction is going to make the block's weight exceed the target weight, then it's probably not going to be included, and it's just going to be returned to the transaction pool where it can then be added to the next block if that were possible. Okay, so that is that for the transaction lifecycle. And so we can then move on to consensus. And now we've discussed how transactions work. We produced blocks. We want to come to a consensus on the actual chain. And so the consensus in Substrate is split into 2 phases. The first phase is block authoring, and the second is block finalization. And they're very self-explanatory. Block authoring just creates new blocks. Finalization handles the forks that may occur during block creation. So first of all, we'll discuss block authoring. For block authoring, there are two algorithms that are used by default. So you have either that can be used, so they're provided as pallets. So the first one is authority round or Aura, and the second one is blind assignment of blockchain extension or BABE for short. And so the authority round basically just maintains a list of authorities that can be used for author, or that can actually author a block, and each authority within that list gets a turn. So every round, the next authority gets a turn and it authors a block, and so on. And so it's just basically round robin scheduling. Um, and that's it for Aura, very simple. Whereas Babe, so for Babe, we still maintain a list of authorities, but it's not round robin anymore. Authorities actually have stake, so they stake a certain amount of tokens, um, and they win uh, rounds based on their stake. And how that happens is they run a verifiable random function, and the verifiable random function just generates some output, and depending on their stake, they specify a threshold. So if the higher their stake, the higher that threshold is going to be. And if their verifiable random function generates an output that is lower than the specified threshold, then the validator gains the right to author the next block. And so it can easily be seen that the higher the stake, the more chances the validator gets to have that output be lower than the threshold. And so they gain more authoring rights more frequently. So that was that for authoring. For block finality, our substrate usually just uses grandpa, and grandpa is it basically just finalizes the best chain instead of finalizing the best block. And how that works is through a two-phase vote. So you'll have a pre-vote phase where the validators are just looking for the best chain. And so what they do is they vote for the block that they think is going to be the best, and they take into account the weight of the whole chain that is attached to that block. Um, and so once they do that, there is the pre-commit phase, and the pre-commit phase only occurs when there is a supermajority that is achieved. A super majority of votes is achieved for a specific chain. So a super majority is just going to be 2/3 of the participants, basically. And so once a super majority is achieved, then the nodes broadcast a pre-commit to the network. Now, once a supermajority of pre-commits is achieved to for a chain, then and only then finalization occurs, and the chain is finalized up until the agreed upon block. So basically, if we get a supermajority of pre-commits for 5A, then the whole chain starting from 1A to 5A is going to be finalized. Um, and that's that. So that is the introduction to Substrate. Very brief. We ran through a bunch of different concepts, a bunch of different mechanisms. So there are bound to be questions. If you have any, feel free to send them to me, and I'll be more than happy to answer you if I have the necessary knowledge. But yeah, so let's jump into the demo. All right, so now for the demo. Before actually doing anything, you'll want to follow the documentation of Polkadot SDK to just download the dependencies. Look at what platform you're using. I'm using Linux, for example, here. So I would install Build Essential, make sure I have all of these packages, and also install Rust, obviously, and that is all detailed over here. So just run these commands, make sure everything is installed, and you're going to be ready to go. So once that's done, by the way, I'll leave all of this in like the description and everything. Once that's done, you'll want to clone the template node repository that they provide. So this is a solo chain template. What you'll want to do is just git clone it, just like that. But I've already done this, so I already have the template right here. I can just change directory into it and then just look at the code. So this is the just a node that is implemented for you, that you can just use for playing around with. Now, you'll see that the file structure actually reflects the architecture that we looked at before in the presentation. So you'll have a runtime and a node, and this node is basically just the outer node that we were talking about, and it provides the RPC stuff. It provides anything that has to do with interacting with the outside world. The chain spec here is the chain specifications. You can change things that have to do with the configuration of the chain using the chain specifications. You can even specify the name of the token that is being used within the blockchain that you're using. But we're not going to get into that right now. We will look at the runtime now. The runtime is where the meat of the whole node is. You'll see that we can look at the configs here. The configs is basically it has all the configurations of any included palette within the runtime. So for example, if we look at let's say Aura, so this is palette Aura here, and this is being implemented for runtime, and we have all the configuration stuff for it. So we're initializing anything that is needed for its configuration right here. And same goes for Grandpa. This is for the finality. We have palette timestamp already included within the node template, as well as balances. So this is all just all the palettes that are being included in the node, and the runtime of the node, and you'll have other things that you can explore as well right here. So the lib will also uh, have the palettes being included here. So you'll include for example, if you create a custom palette, which is the case here for palette template, you'll include the config, and then you'll also go into librs and include the palette itself down here in the runtime module. Okay, so now that we have gone over this, we can look at the palettes folder. So the palettes folder is where you'll implement your custom palettes. So we have a custom palette already implemented for us, which is template. And if I take a look at the implementation here, you'll see that it is a very simple palette actually. So all it is basically this something storage value, and all it does is just store a number, right? A U32 value, and the way you interact with it is through the transaction, or well, in our case, it's called extrinsics in the Polkadot ecosystem. So this do something extrinsic is going to just take a something which is of type U32, and it will put it into the something storage value. Once it does put it, it deposits an event, so that the event is broadcast to the whole network, and then we can see that the event actually, or that something was actually stored in the something storage value. There is another transaction here which is cause error. This is just to show how custom errors can be implemented within Substrate. So these are the custom errors that you can implement. It's just an enum, and then you just call the error itself, throw the error right here. For custom events as well, events are enums, and you can have whatever parameters that you want. So the same goes for errors, by the way. You know, whatever parameters you need to relay over through the event. So that is a quick rundown of the template palette. And the way so now we just want to run the node itself. So we're going to run the blockchain, and the blockchain is just going to be comprised of one node for now. And the way I'm going to do that is well, first of all, you want to build the project. So make sure you're within the directory of the template node, and you'll want to run cargo build with the release target. Now this takes a long time. I've already built it, but don't worry if it takes a while. It was going to take a while. So once it is done building, you'll have this target folder right here that is going to be generated. You'll want to run the target release Polkadot, what's it called? Solo chain template node binary. And so that's the actual node binary that is being run. If you just run it like this, you'll see that the node runs and everything. But then you'll have these heartbeat logs, and you'll see that we have no blocks being produced or finalized. And this is because the node has no authority set up and everything. So if you want to get through this quickly, you can just run the node in development mode, and the node is going to be like an authority. So you'll see that the role is actually an authority here instead of being a full node like up there. And now that it's an authority, it can actually produce blocks and finalize them. So now we have where we produced 3 blocks, or authored 3 blocks and finalized 1 onto the chain. And right now we're at 4 with 2 finalized, and so on. So nice. Now we have a 1 node blockchain running on our system. We can actually interact with this through the Polkadot Explorer. It's just a UI that is provided by Polkadot, and you can interact with your local node through it. So all you have to do is go into click here and for this sidebar to come up, and then go into development and click on your local node, and it's going to be running at the 9944 ports by default anyway, so it's going to connect for sure. So once it connects, you can see the recent blocks that are being produced, and you can see that the target is 6 seconds per block for the block production, and the time since the last block was produced. And so you can click on the number associated with the block, and you can see what extrinsics are included within the block, and all the details of the extrinsics as well. Okay, so we want to actually interact with the template palette that is included in our node. And so all I'm going to do is go into extrinsics here, and I'm going to select the template palette right there, and I'll select the do something the do something extrinsic. And so this do something extrinsic allegedly just stores some value in the something storage value. So I'm going to store 34, and then I'll submit the transaction as a signed transaction, and I'll wait for it right here. And as you can see, it's done. So if I just go back to the Explorer real quick, you'll see that the recent events tab has actually been updated. And so with the something stored event, which was defined in our code right here, let me just go down really quickly. So the something stored event has the something, which is the value, and the who, which is the address of whoever submitted the transaction. And so we have these right here. So the something was 34 and the who was Alice. If I want to check that the something was actually stored, I can go and query the chain state. Same way, I'll just select the template, and then I can select the storage item that I want to query. Now this is just a storage value, so I can just query it, and I'll see that I have 34 actually being stored there. So I mean, this is kind of redundant, but just to make sure that yeah, it's being updated, we can store 17 now, and then sign the transaction, and then go back and, well, so the transaction was successful, we can then go back into the template and then query it, and we'll see that we have 70 now being stored in the storage value. So that is it for the template node. All right, so now we want to customize our palette. We can create a completely new custom palette, which is relatively simple. All you have to do is, well, either you cd into the palettes directory and then cargo cargo create dash dash lib, and oh well, let me just type out the command dash dash lib and give it a name, for example tester, and that will create a new library within the palettes folder, but that will be missing a few things like the tests and the benchmarks, which are I'm not going to go into in this video, but they are detailed in the documentation. An easier way is to just copy the template palette and paste it within the palettes, and then change some things. So the first thing you're gonna want to change is the cargo toml. Change the name of the palette. You might want to change the description as well. The next thing is you'll go into the mock and change any references to the template palette and make it the name of the palette that you created. Is going to be the same thing is going to be done in tests. Weights are automatically generated. You're going to run a command, the benchmarking command, to generate that. Which I'm not gonna go into in this video as well. The other thing that you're gonna want to do when registering a new palette is you're going to want to um, include its configuration in the configs file, and you'll also want to include it in the runtime module right here. So you just copy paste this and increase the index and include it in there. And you'll also want to include it in the workspace. And so like in the root cargo toml, just like here. So you're gonna just copy this over and create include your palette, and you'll also want to include it in the cargo toml of the runtime. I'm not gonna go through all of this. I'm just going to customize the template palette because it's easier just for the sake of the video. All right, so for the purposes of demonstration for this video, I'm going to be implementing a simple storage map in the template palette. And so the way I'm going to be doing this is by first using the same directive as was used for storage value, which is palette storage, and then I can say pub type, let's say test map, and this test map is going to be, hold on, okay, test map is going to be a storage map, and that storage map is going to take first a prefix. That prefix, we're not going to pass anything there. The default is going to be the same, the name of the map. The second parameter is the hasher type. I'm going to use a Blake to 128 concat, which is the default hasher that is used in the storage maps. The third is the type of the key. I want to store strings and map them to random arbitrary U32 values, and so usually you'd want to use a vec of chars for that to represent a string, but it is recommended to use a bounded vec, which is just a bounded vector basically, and it's provided by one of the frame palettes. I don't remember which one, but it is provided, so you can just use a bounded vec and give it the type of the element that is being stored in it. So it's going to be a U8 in our case because we want to store characters, and the maximum size of the vector. So I'll just define it as vec size for now, and we'll define it later. And so this is the key. The value is going to be arbitrary U32 values, and final parameter is the return type. I'm going to use an option query right now. This doesn't matter too much because we're not going to be querying the test map in our code at all for this demonstration. Okay, so now I'll just define the type, the vec size, so we can just define vec size really quickly as a const u32. Let's say it'll be 100. Like the maximum size is going to be 100 characters. Okay, so now the storage map has been defined. I can create a quick event as well. So let's say it'll be test event, and test event is going to take test test key, and the test key will be a bounded vec of u8 and of size vec size, and then the value, I guess, is going to be some, I'll just call it val of u32. Okay, test key. All right, so I'm not going to define any errors. We will then create a new extrinsic. All I'm going to do is just go copy the something extrinsic over. We will want to change the call index to 2 because the last one is 1. And then, so usually you'll want to use the weight of the actual extrinsic. In our case, I'm not going to change this because it doesn't really matter. But when you're actually working on an actual pallet, you're probably going to run your benchmarks, generate an actual weights RS, and then you're going to be able to access the weight that is generated for the extrinsic. So I'll call this test extrinsic, and I'll take a let's say test key, which will be a bounded, again a bounded vec of u8 and vec size. And I'll just take something u32 as the other parameter. All I'm going to do is just update the storage now. So instead of updating the something storage value, I'm going to update the test map. So test map, and I will want to insert the key, which is going to be the test key. I'll pass a reference to it, and the value, which will be something. All right, so that should be good to go. Now that we are inserting, oops, all right. So now we're inserting the key and the value into the test map. We can deposit our new event, which is the test event. We'll call test key. Well, we don't really need to specify the key, right, for the enum, but then the value is going to be val something, right? Okay. The reason we didn't need to specify this is because it's the same name, so I'm using test key here, and the event itself has test key defined, so it just maps them together. Okay, so now we just have the extrinsic going. We can just rebuild our binary, which is going to be cargo build -- release, and it's not going to take as much time as the initial build took, but I'll be back once it's done. All right, so now that the build is done, we can just run the binary like we did before. What was the name of the binary? Solo chain template node, and then run it in dev node, just so that we have an authority running, and we'll have some blocks being authored. So now we have the node running, the blocks are being authored and everything. We can try and connect to the network. So because it was connected to the node before, and that node was kind of like taken down, it's going to take a little bit of time until it actually finds the node. Can try and kind of like force it to refresh. Can clear the cache really quickly. Yep, there you go. So yeah, so now we're in the Explorer, everything is working. We can look at the chain state and go into template, and we'll see that we have test map as a new storage item that we can interact with. So I can just give it some random test value and then try and query it, and you'll see it's none because there's nothing stored there. We can then call the extrinsics of template. So you'll see that the test extrinsic that we added before is here. And so I can pass test, and let's say we'll add 74 as the value, and then I'll just submit a signed transaction, and I'll just wait for the transaction to go through. And it did. We go to Explorer, and you see that the test event was fired. Great. So now I can go to the chain state template and test map, and then query for test, and you'll see that I have the value 74 here. So that was that. That was a very simple demonstration of how to customize your palette. You could create a custom palette just as easily. And as you can see, like it is endless what you can really do with this. You could even try and customize the consensus of your node if you if you really want to. You could, there are some concepts that I haven't delved into, like for example unsigned transactions and how to implement your own validation mechanism within your palette. You can also implement off-chain workers using hooks. So that can be done at a later date, I guess. But for now, this is a very good introduction if you want to start working with Substrate. That's it. Thanks.